So our project has to deal with a little different problem than those of technical problems that you'd be seeing throughout the morning. We are taking one step, well, actually 5 or 6 steps back in order to try to explain what do you need to do to embed an AI-based component into a system-critical or a mission-critical system, which are usually larger than just the IA component. So that's what we've been working on for the last 2 years. So last year, we produced a lot of material, interesting material. Batch 1 results were currently 6 state-of-the-art, meaning we try to investigate what's been going on, what's the state of practice also, and the state of the art on algorithm engineering, data engineering, knowledge engineering, systems engineering, including model-based systems engineering, which is, as you will see, one of the main viewpoints that we are taking to try to formalize all of this. Safety engineering, and human factors and cognitive engineering. This has served as some sort of input to produce some other material which we are currently using or evolving concerning, for instance, the first version of Confiance.ai taxonomy. This is going work. This is a living material. Trustworthy machine learning engineering guideline, first version. This has been formalized, as Boris will explain, into a modeling environment that will help us make sure that every engineer that concurs to producing such systems are connected and going in the same direction. Trustworthy attributes, I will talk very briefly about this, but I suppose that if you go to the village, you will have a much clearer explanation either by Juliette or Agnès, who are somewhere here. And then systems engineering analysis framework. These are just a collection of points of view and viewpoints that allow us to analyze each of the incoming different disciplines or engineering from different point of views, be it safety, security, trust, or even global engineering processes. So this is what's been produced last year. The objects that you see on the right-hand side of the screen are those that we are still working on and will evolve certainly, most probably until the end of the project. We've also published, well, these are not just Project 2 publications, this in general, which is a very good thing within Confiance.ai. These are done jointly with several other projects. You see some papers presented on the System of Systems Engineering Conference, Safe AI Conference, and CAID Conference in 2021. These are published, so if you need the references, don't hesitate to come back to me or one of the authors of the papers. Basically, what we are planning to do for the next delivery at the end of the year is going further into the definition of attributes, metrics, and methods to assess the trustworthiness of AI systems, architecting and modeling the trustworthy environment. This concerns workflows, flows, connections, activities to perform. We are trying to also capture, like I said, all the different engineering processes into a modeling framework, and then go all the way to defining, or rather refining, yes, the end-to-end vision and methodology for trusted AI systems engineering. And we are also just started to investigate human and AI interaction thanks to what Boris will present later, Cogment solution that help us combine artificial and human agents to learn throughout the product lifecycle. So we will briefly describe each of these different topics. I'll start with the first one, but like I said, my explanations will probably be disappointing if you already discussed with Agnès or Juliette. So I'll try to be very brief. The challenge here is to establish objective trust criteria through clearly identified attributes. And then we'll try to map these into different AI systems engineering activities in the life cycle. And then the last, what we expect to come up with is a unified approach based on assisted multi-criteria decision making. So what attributes are you interested in depending on the criticality or on the type of systems you are working on, and then making a choice and helping you come up with some sort of score of trust. Other activities concerning the attributes, the Confiance.ai attributes, are of course our participation to different standardization initiatives, mostly in Europe, on trustworthy characteristics. So once again, if you want to have more information, come to the village, and there's a presentation tomorrow morning on this very topic at 11:30. So with that, I just handle the mic and the control to Boris.
Thank you, Guillermo. So regarding the activity of elaborating an end-to-end method for engineering trustworthy AI systems, so we are currently elaborating this method according to two different approaches. So we take two main sets of inputs in order to build this end-to-end method. This end-to-end method is necessary for us because we think that the focus should not be only the AI component, but also the system that includes this component, because what will be on the market and what will be on the road or in the air will be a full system and not just the AI component itself. It will be an AI component integrated into something bigger. So we need this end-to-end method to engineer a full system based on AI components. And so to design this method, we use two main sets of inputs. One set of inputs, what we call the top-down approach, is to start from the ongoing standards like ISO 5338 or SAE 6983. So that's one set of inputs. They are not released yet, but we take them, the in-work state as input, because we think that, of course, the end-to-end method output by Confiance.ai will have to be compliant with these standards. And the other set of inputs is the set of technological, methodological bricks developed inside Confiance.ai. For example, regarding how to make robust by design models, how to make explainable by design models, how to embed an AI model into a specific target. All the different ECs inside the Confiance.ai program produce each local method that we need to take as inputs to make sure that our end-to-end method integrates them correctly and that all these local methods can communicate with each other, that they can be assembled together to produce a fluent end-to-end method from start to end. These are the two sets of inputs that we consider for the moment, but by elaborating our method, we may notice that maybe some things are missing. Some parts of the end-to-end method are missing yet because they are not addressed yet in the Confiance.ai program. So this integration of local methods may reveal the need to start new action sheet, new works inside the Confiance.ai program. And what I can say also is that we use the modeling in order to make sure that these methods are correctly formalized and that they can be connected all together thanks to outputs of a method feeding the inputs of another method. So as I say, we use modeling, and the modeling of engineering processes is just one part of the whole modeling process inside the Confiance.ai program. As you can see on the pyramid, the top of the pyramid is what I just explained, the modeling of engineering processes. But then the follow-up of this modeling is to model what the trustworthy environment that will be delivered by Confiance.ai program should be able to do in order to provide services to the users, in order to help the users to apply these engineering processes that we will recommend. And at the bottom of the pyramid, it's the architecture of the trustworthy environment, because in the end, the trustworthy environment will be made of various software components produced by Confiance.ai or maybe produced by the state of art or bought in the market. And we need the full traceability from the engineering processes at the top to the to the concrete resources of the trustworthy environment at the bottom to trace what components of the trustworthy environment what each software component help as a process for the final user of the trustworthy environment. So the modeling helps us to have this fluent traceability between the process need and the tooling environment. So our main outcomes we have on the right of this slide. You can see, as I said, the end-to-end methods that will assist the engineers from start to end how to build a trustworthy AI engine system. And we have also another output at the left of the current slide. It's the set of main principles that everybody should have in mind when deploying AI in its enterprise. So on the right, you have a kind of user manual of how to build a system. On the left, you have a set of principles to keep in mind at every step of your deployment of AI inside your context. And what you can see at the center of the slide is that one of the difficulties is to make different domains work together at each step of the process. We have different engineering domains that need to collaborate, and that is why we need the modeling and the formalization of methods to make sure that we have a fluent connection between all these domains at every step of the process. And one final topic for us is the human interaction between AI and human. And for this, we have currently an experimentation, an evaluation ongoing with a Canadian startup, which is called AI Redefined. So this experimentation is based on their tool Cogment, which is a tool that allows to build a AI model based on the ongoing interaction between the human and machine. So they have a different philosophy than most other tools, so we need to assess what is the specialty of their approach. And we are currently evaluating this tool by implementing it on the use case provided by Renault about the welding control.